Okay, so I'm going to go over compass and true bearings. Before I do that, I'm just going to do a brief recap on what I mean by a degree and a compass. So a degree is a measure of turn. So for instance, 90 degrees, the dots at the top denotes we're measuring in degrees, is a measure of turn of 90 degrees. If you remember, 90 degree is a right angle. Okay, so a bearing is the direction one object is from another object or a fixed point. So I'm going to define my fixed point with a red dot, and I'm going to say my fixed point is in the middle there. Okay, so we use 4 directions of the compass, and I use this acronym: never eat shredded wheat. Okay, so we define the top arrow as north, going around clockwise, east, south and west, and we say that each quadrant measures 90 degrees. So that is 90 degrees. Okay, we can further split our quadrants by this bisector here, and this is defined as northeast, southeast, southwest and northwest. And because it bisects our quadrant, we say that this makes an angle 45 degrees. 45 degrees. North-south is the vertical. So this line here is vertical, and east-west is horizontal. So this line here is horizontal. And in between are the directions northeast, southeast, southwest and northwest. Okay, so let's define a compass bearing. Okay, so compass bearing is different from a true bearing. And let's just relabel our compass. I'm going to say north, don't want that one, north, east, south, west, and we can further split these into northeast, southeast, southwest and northwest. Okay, so I'm just going to give some examples of a compass bearing. So for instance, northeast, if we define it under a compass bearing, is going to be north 45 east. Now, we always name the direction going from north or south. So for example, if we were to name this bearing here, let's say for example this is 10 degrees, we would call this bearing, let's use a different colour, north 10 east. Okay, so let's look at some other examples. How would we define southeast as a bearing? Well, pause the video and see if you can do southeast, southwest and northwest. Okay, so you should have done that now. So southeast, remember, with compass bearings, we always measure from south. So this is going to be 45. This is going to be south 45 west and north 45 west. And north, east, south, west are also compass bearings, and we don't need to insert the degrees or the second direction. Okay, so let's look at a problem. Okay, we need to write A, which is here, from O as a compass bearing. Now, we're either going to measure from north or we're going to measure from south. Now, since A is there and we've measured 20 degrees from north, we're going to get north 20 east. Now, let's suppose we were given only this angle and we were told that that was 70. A would never be north 70 east. That is wrong. That is wrong. Very wrong. It's wrong because we always measure our compass bearing from either north or south. Okay, so if we were just given 70 degrees, we would have to subtract that from 90. Because if you remember, there's 90 degrees in each quadrant. Four quadrants make 360 degrees. So we can write this in. It's north 20 east. Okay, so let's write B from O. Okay, now using the same logic, B is going to be south east. Okay, now I want you to think why this compass bearing is wrong. This compass bearing is definitely wrong. Can you come up with an explanation why this compass bearing is wrong? Pause the video if you need to. Okay, so this compass bearing is definitely wrong, put a cross there, because we haven't measured from the south. Remember that a compass bearing always starts from either a north or a south and is measured from north to south. So B here should be south. We know that this here is 90, so 90 to 100 to 110 is 20 degrees, so we know that this must be 70 degrees. 70, 80, 90. So okay, now before we go on to true bearings, I just want to redo each of these and write in the compass bearings. Perhaps you can pause the video and write in all the compass bearings. Now I'm going to give you an example. Let's consider the compass bearing of west. Okay, so we would just write in for west as a compass bearing, it would be just west. If we wanted to write in, for instance, northeast, we would write north 45 east. See if you can pause the video and complete the rest of the compass bearings. Okay, so you should have done that now. So let's quickly label the directions. This is south 45 east. This is just south. This is south 45 west. and this is north, 45 west. Okay, so just to recap, a compass bearing either begins with north or south, and either ends with east or west. So let's put start and end. Okay, let's do 2 more examples and then we'll go on to true bearings. Okay, so I'm going to give you a direction, and I want you to write this as a compass bearing. I'm going to define the origin O, and I'm going to say I want you to find, let's do 3 examples. Okay, so I'm going to say this is A, and I'm going to measure this as, let's say this is 30 degrees. Let's do this one. I'm going to say that this is 10 degrees. We'll call that B. And then finally, I'm going to say that this one is C, and I'm going to say that this is 25 degrees. Okay, so pause the video and I want you to write each of these as a compass bearing. Okay, so you should have done that by now. So let's label never eat shredded wheat, and let's input the directions. So this B, I'm going to write B and a colon, and it's definitely never east, definitely in this quadrant. Okay, now we always measure from north. So if you're going to measure from there to there, you're going to have to add 80 to 10 to get to 90. Okay, so let's do, started with B, let's do A. Okay, so I'm in this quadrant, so it's just definitely going to be south, east. We don't use the angle 30 because we need to measure from south. We need to add 60 to 30 to get to 90. Okay, now finally for C, I'm going to do a different colour. Or I don't know, let's do purple. So I'm going to do C, I'm going to do a colon. We're definitely in this quadrant here. So what do we need to add to 25 to get to 90? Because we're measuring from north. We're going to have to add 65. Okay, it's not really clear. Okay, north 65, because 65 plus 25 is 90. Okay, so let's have a look now at true bearings. Okay, so let me just give you a quick example of what a true bearing is. For example, the smallest true bearing is 0, 0, 0, and we denote a T after the true bearing to distinguish from other types of bearings. Okay, before we do that, there's 3 really important points which you need to know about bearings. Okay, the first one is always measured from north. Measured from north. Okay, the second one is they're always 3 digits. So I'm going to write 3 digits. And the third one is they're always measured clockwise. Okay, so compass bearings are sometimes measured clockwise, anti-clockwise. True bearings are always measured clockwise. So make sure you write these facts down, please, and memorize them. Okay, I'm going to get rid of them because I don't have space. Okay, you should be familiar with the various directions, so I'm not going to put those in. So the next one is going to be 0, 4, 5 degrees T. Continually measuring clockwise. Okay, I want you to pause the video and you should be able to fill in the rest of the compass bearings. Okay, so I'm going to do this very quickly. Measuring clockwise, this is 0, 9 degrees T, 1, 3, 5 degrees T, 180 degrees T, 2, 2, 5 degrees T, 270 degrees T, and then finally 315 degrees T for true bearing. Okay, so let's select one of these true bearings. Let's say, I don't know, 270. Now, why is this 270? Why not 300? Pause the video and I want you to come up with an explanation. Why is that 270? Okay, so you should have figured that out now. So I'm just going to go over this explanation. Okay, so if you remember, the true bearings are always measured from north. So this is north here. We always measure clockwise. Let's do that then. And it's always 3 digits. If we measure clockwise here and go around 90 degrees, 180, 270. Okay, that should be pretty straightforward. Nothing complicated about this. Let's do one more example before we move on. Get rid of all this. Now, I'm going to tell you that we've got a new position. Okay, and this position is measured here. I'm going to say that this is position X. New position X. And I'm going to say that this position X is 10 degrees from southwest. I want you to find the position of X. I'm going to define a new position. Let's go with Y. And I want you to find the position of Y given that this is, let's say, 20 degrees. Okay, pause the video and I want you to find the true bearing of X and Y. Okay, so you should have done this now, and this is pretty straightforward. Let me choose a colour which we haven't had. I don't know. Pink. Okay, so if you remember, if you measure clockwise down here, this is 180. If we measure all around here, this is southwest, which was 225. Now x is 10 degrees before 225. So I'm going to write this down below. I'm going to use a little colon, and I'm going to say that 10 degrees before 225 is 215 degrees true bearing. Okay, the same logic for y. Let's use a different colour to distinguish. Okay, I'm going to use blue, and I'm measuring clockwise. I'm going to go inside here. So I'm measuring clockwise there. So y is 20 degrees from 360. So if we subtract 20 degrees from 360, we're going to get 340 degrees. Okay, nothing complicated there. So let's have a look at some questions. Okay, pause the video and write the true bearing of each of these. I'm going to write this at the top. True bearing. Okay, so you should have done that now. So Q from O is 220 degrees T. It's pretty straightforward. Okay, we are measuring clockwise from north, and it's 3 digits. Okay, now P from O is similar to the last one we did. Okay, so we're going to measure. Let's do it around here, and that is just the same as 360 minus 20, which is 340 degrees true bearing. Okay, now pause the video, and I want you to state the compass bearing and the true bearing of each of the following. Okay, so you should have done that now, and I'm going to put the compass bearing in green, and I'm going to put the true bearing in dark blue. Okay, so which quadrant are we in? We're in the north-east. We always measure from north, so this is going to be 50 degrees. Which quadrant are we in? We're in north-west, but we always measure from north or south. Okay, we need to add 65 to get to 90. Okay, a little bit more complicated here. So I'm gonna add some axes here. Let's choose the color black. Okay, so I'm gonna do this. Jeez. Okay. I'm still going to do that, but I'm going to choose a different thickness. Okay, let's do that thickness. It's better. Okay, and let's continue this going down there. Okay, so we're told that this is 240, but we know that, let's do this in red, from there to there is 180. So if this is 240, we know from there to there it's going to be 60 degrees. So the compass bearing of this is going to be we're in the southwest quadrant. So southwest, what does it measure from south? So 60 degrees. Okay, let's do the same here. I'm not going to bother this time doing the fiddly bits. I'm drawing in freehand. So we're told that measuring anti-clockwise from north is 250. So we can do some deductions. We can say, well, if from there to there is 180, this angle from there to there must be 70 degrees. Okay, which quadrant are we in? We're in the southeast. And we're 70 degrees from southeast. Okay, so the true bearing is rather easier. Okay, so we are measuring clockwise from north. We measure clockwise from north. That is going to be 050 true bearing. Okay, now, really important. Measuring clockwise from north. Okay, so we should know that 3/4 of the way around is 270. But we've got an extra 35 degrees. And that is 305 degrees true bearing. Okay, the true bearing is given here. Just 240 degrees true bearing. Now, a little bit more complicated. We are told that E is 250 counterclockwise from north. Well, we need clockwise from north. But we are told it's 70 degrees from south. So 180 minus 70 is 110 true bearing. Okay, so you've got a little problem to do. A boat sails 137 kilometres from Sydney on a bearing of 65. Okay, so how far east has the boat sailed? How far north has the boat sailed? I'm going to give you a hint. You're going to be using trigonometry for right angle triangles, and you'll need a scientific calculator. Well, let's do this then. Okay, so I'm going to do all these calculations in blue. Okay, so a boat sails 136. So let's say this is Sydney. Okay, it sails on a bearing of 65. Okay, so say this is 65 degrees. Well, this angle here then must be 35. Sorry. Must be 25. Okay, so that was just a quick test. Okay, 60, 70, 80, 90 degrees. Okay, our right angle is here, and we know that this is 137 kilometers. Okay, now I'm going to rub out this 65 because it may confuse us. Okay, now the position of the boat is there. Position of the boat is there. So it's saying how far east. So we're looking at this direction. So let's label our right angle triangle using trigonometric terminology. Well, isn't this going to be the opposite? Since it's opposite the angle, the longest side is the hypotenuse, and this is the adjacent because it's next door to the angle. So we need southeast, which is the adjacent, and we've got the hypotenuse. So we're going to be using cos. So for A, we're going to be using cos theta is adjacent over hypotenuse. So let's input everything. Got 25. The adjacent we need to find, and we know the hypotenuse is 137. I've written 135 for some reason. Okay, back on track. 137. Okay, so we need A equals. So we multiply both sides by 137. 137, 137. They cancel. So we get 137 cos 25 degrees. Okay, they haven't stipulated an accuracy, so we assume 2 decimal places. So make sure your scientific calculator is in degree mode. So we've got 25 cos multiplied by 137. Okay, so I'm going to do two decimal places, 124.16 kilometers to 2 decimal places. Okay, so how far north? So pause the video and write this down, because I'm going to have to rub it out because I've run out of room. How far north is going to be finding the opposite. So let's do that then. Okay, let's choose a different colour. Colour we haven't had. It's an interesting colour. Okay, so we need to find the opposite. Opposite there, and we know the hypotenuse. Okay, so we know that is the sine ratio. Sine theta is opposite over hypotenuse. Let's fill it in. Sine 25 degrees. Opposite, we don't know. Hypotenuse is 137. Okay, so the opposite is 137 sine 25. Okay, we get that by multiplying both sides by 137. Goes 137. Okay, so again, it doesn't state an accuracy, so we assume 2 decimal places is a good place to start. So 25 sine multiplied by 137. So opposite is 57.90 point kilometers to 2 decimal places. Okay, that should be a introduction to bearings. It is by no means an exhaustive tutorial, but it should give you some of the fundamental definitions, and for HSC students you will need to complete the rest of the questions in your relevant textbook. These are popular questions in HSC general standard exams, and you'll need to know them in a pretty fundamental way if you're going to successfully answer these questions. So good luck.